Hi, welcome back. This is Professor Ridge, and today's lesson is on section 7.3, the hyperbola. Now there's a lot of similarities between the hyperbola and the ellipse as far as the equation goes. So we're going to skip the first one and just go straight to the standard equation with the center at HK. Okay, so again, there's a lot of similarities with doing the ellipse. Sorry, let me spit that out here. Okay, so here we have HK as their center. And then basically, just like the ellipse, I'm going to look under the X. I'm going to go in the X direction plus A. In the minus direction, minus A. Provided, A is a positive number. And then B, I'm going to go up B, down B, and then what I do is I'm going to make we call this the fundamental rectangle. Now this book doesn't talk about that. And what I'm looking for is these corners is for the asymptotes. Basically here. So if you look at the asymptote right here, B, that's the slope. So if I go up B over A, that's that corner right there. So if I draw the line that goes through the corners of that fundamental rectangle and through the center, that's going to give me my asymptotes. So I need this corner, and now that corner, that's the minus B over A. So let's go down B over A, and you get that slope. Now, the key to this is the vertexes. The transverse axis, by the way, is where you connect the two vertices. Is the line segment there, or if I extend the line, right? That's called the transverse axis. Transverse axis. And then the hyperbola is going to look like this. Remember, the asymptotes, basically the further you go out, the closer that this is going to get to that line. It's going to resemble that line at the extreme ends. And same thing here. Alright, so that's how you do it. Now you don't have to draw the asymptotes, they just make it easier to draw their tools. So the only part of the graph is the two curves, the last two things I did. Okay, that's the actual graph. All the other stuff is just extra just to help me draw the graph. So now let's write the one for the vertical transverse axis. Okay, so again, if we have a transverse axis that's vertical, we find the center. So let's say here's HK. And then from the center, I look under Y, I go A, so I'm going to go up A units, down A units, and then I'm going to do under X is B, square root is B squared, B, B, and then I get my fundamental rectangle, get the corners, right, that gets the slope of my asymptotes. Get out my ruler, draw the line through those. Should have made it skinnier. Oh well. Okay, and then I start, now my vertices will be, this is my vertex. Vertex is on the Now the way to do it is see y, notice the y minus k squared over a squared, that's the one that has the plus in front of it. And then we have minus x minus h. So I'm looking, the y tells me that it's vertical. So these 2 points are the vertices. That's the vertex. This is the vertex. There you go. So that's how you do it. Okay, so center is going to be 0, 0. Right there. Now again, I'm going to look under the x. That's going to be 1, so I'm going to go in the x direction 1, y direction 1. I mean, plus 1, minus 1 in the x direction. And I'm going to look under the y is 3, so I'm going to go up 3, down 3, make my fundamental rectangle. I guess I could have used the full scale. And let me draw it again, just to show you. Okay, so the center is 0, 0, and then from there, under the x is 1, so I'm going to go plus 1, minus 1 from the center. Under the y is 9, square root of 9 is 3. So up 3, down 3, counting from the center. Now I'm going to make my fundamental rectangle. Now you don't really need to draw these dotted lines. You just need the corners because that gives you the asymptotes. Okay, and then you decide, okay, is it opening in x direction or y direction, right? So the first one, the positive one, opens in x direction. So open side to side. So start from here. Don't go inside that fundamental rectangle, and you're going to kind of curve out to your asymptote. There you go. And now let's label all the stuff center 0, 0. So the vertices are, remember it's positive 1, we're adding 1, subtracting 1 from the x coordinate. And foci, we got to figure out or c squared equals a squared plus b squared. So remember, on an ellipse, the center sign is a plus, and you subtract a squared minus b squared. For a hyperbola, this is minus, so for c we add. So it's just the opposite, if you remember that. So let's see, we're going to get c squared equals 1 plus 9. So c squared equals 10. So c is square root of 10. So we're going to add, subtract square root of 10 to the x coordinate because it's opening side to side. So it's going to be square root of 10, 0, and negative square root of 10, 0. Okay, so there's the foci. And then the last thing is the asymptotes. And you're going to get the x minus h is 0. It's going to be y asymptotes. Y minus k equals, and the way I think of it is change of y over change of x. It's slope. X minus h. So I'm going to get y minus 0 equals slope. So basically we're looking at this, the change of y is 3, change of x is 1, and then x minus 0. So it's just y equals 3x. And then just, it's the same equation, now make the negative slope. Y equals negative 3x. So those are your asymptotes. Alright, let's try another one. Okay, so let's see, our center is going to be, now remember HK, x is with x, the h is with the x, the x coordinates with x, that's the way I think of it, so that would be negative 3. Y is with the y, so that would be positive 2. Remember, change the sign. Now this one's opening in the y direction. So all our stuff for the vertices and foci, we're going to add it to the y coordinate. So we're going to do a is plus or is 4, so I'm going to add 4, subtract 4 to the y coordinate. So it's negative 3, 2 plus 4, and negative 3, 2 minus 4. So that's going to get me negative 3, 6, and negative 3, negative 2. Okay, so that's my vertices. And then my foci, again, some people say foci, so either one. Foci or foci. Okay, so again, this opens in the y direction, so all the a and c is acting on the y coordinate. So c squared equals 16 plus 4, so c is square root of 20. So I get negative 3, 2 plus square root of 20, and negative 3, 2 minus square root of 20. And then my asymptotes are, now remember, my slope is going to be change of y over change of x. So change of y is 4, that's just the a, and then under the x, square root of 4 is 2, so that reduces to 2. So my asymptotes are y minus 2 equals, the slope is 2, x plus 3. So you just write exactly what's in the parentheses for the y and the x. And then now you change the slope to negative. Y minus 2 equals negative 2, x plus 3. Okay, let's graph this. Next page. So the center was negative 3, 2. In the y direction, I'm going to go up 4, down 4. The x direction, I'm going to go right 2, left 2. Make my fundamental rectangle. Oops. Draw my asymptotes. So this one is y minus 2 equals 2x plus 3. I'm going to do this asymptote, which gets me that one's y minus 2 equals negative 2, x plus 3. And this one's opening in the y direction, so we start with the vertex. And you're just going to kind of curve out. to the asymptote. So again, the asymptote's a nice tool to help you graph these things. Of course, I can pick points and plot them, but that will take forever. So there you go. That's the hyperbola. Let's do another one where you got to complete the square again. So let's see, we're going to put the positive one, that's the direction it's going to open. So we got 9y squared minus 18y plus, or minus 4x squared plus 24x. We'll put the 63 on the other side, so add 63. Now we're going to factor out the y just like we did, the 9, plus blank minus blank, minus, factor out the negative 4. Now be careful, you're dividing both of them by negative 4. So 24 divided by negative 4 is negative 6, plus blank minus blank, 63. We're going to complete the square. 9 minus 1 squared, 1 squared, add it, subtract it. So you got the minus 1 left over. Half the middle term, x minus 3 squared. 3 squared is 9, add it, subtract it. Got the minus 9 left over. And remember, you're going to distribute this 9 to think of this y minus 1 squared as one number for a moment. So it's 9 times y minus 1 squared minus 9. Same thing with the negative 4. Negative 4 times negative 9 is positive 36. Got to be careful there. So I'm going to add 9, subtract 36, subtract 36. So I get 9 y minus 1 squared minus 4x minus 3 squared, 63 plus 9 minus 36 equals 36. Is that right? Let me try that again. 63 plus 9 minus 36. 36, yep. Okay, and then we want it to be equal to 1, so we divide by 36, just like we did with the... So there's no difference doing this technique with hyperbola or an ellipse, just the minus sign in the middle. So 9 goes in 36 4 times. 4 goes in 36 9 times. And now we can answer all our questions. So let's see, our vert, this is going to open in the y direction, just like the one above. So our center is going to be 3, 1. Our vertices are going to be, see, it's opening y, so opening y, square root of 4 is 2, so we add 2, subtract 2 to the 1. So that's going to get us 3, 3, and 3, negative 1. And let's see, what else do we want? Foci. So we're going to do 4 plus 19. 4 plus 9, which is 13. So that's square root of 13. And we add it to, again, what's opening in the y direction, so we're going to add it to the y coordinate of the center. Plus square root of 13. And 3, 1 minus square root of 13. And then our asymptotes are going to be y minus 1 equals, and remember, it's change of y over change of x, so it's 2 over 3, x minus 3, and then just change the sign of the slope. So there you go. And then I'll leave it for you to graph. Okay, so that concludes the lesson for 7.3. Go to my math lab, complete your exercise there, and I'll see you next time.